Hi there. In this video, I want to help you understand phase shifting and all transformations of the sinusoidal functions. Our objective is to graph sinusoidal functions of the form y equals a times the sine of the quantity bx minus c plus d, and y equals a times the cosine of the quantity bx minus c plus d. Different textbooks will use Greek letters like omega and phi and other things like that. We're going to use A, B, C, and D. Alright, here's the transformation form of a sine function. I'm using color to show you the different components. A is the vertical stretching and compressing, which will correspond to our amplitude. The coefficient B inside with the x is the horizontal stretching and compressing, which will correspond to the period. The horizontal phase shift is going to be represented by our letter C, but if you notice, I'm showing you that phase shift will be found by doing C divided by B. And on the outside, when we're saying plus D, that is corresponding to our vertical shift. Okay, I just wanted to briefly show you how did I come up with this C divided by B term. So I'm going to start with Bx minus C. If I wanted to factor out the coefficient b, I would divide both terms by b, and I would be left with x minus c divided by b, and that b coefficient I factored out would now go on the outside. If I redistributed, you would see I would get bx minus c back. So this is just an alternate form to show you for the purposes of us understanding how we're going to find our phase shift. Alright, just wanted to remind you that the amplitude is found by taking the absolute value of A. The period is found by doing 2 pi divided by B. The phase shift again will be found by taking C divided by B, and our vertical shift is D. On the right hand side, you can see here I have written some steps for graphing a sinusoidal function, so you might want to write these down. Sometimes I'll take these steps out of order, but in general, these are the steps I'll use to graph our sinusoidal function. Let's start with the first example. Find the amplitude, period, and phase shift of y equals 3 times sine of the quantity 2x minus pi, and graph the function. So the first thing I want to do is I want to make note of my A, B, C, and D values. So I'm just going to write those above. A, B, C, and you can see here we don't have a D value. That D value is 0. There's nothing being added or subtracted in back here. Alright, to find the amplitude, we're going to take our A value of 3, but we're going to take the absolute value of 3, and so our amplitude is 3. Remember, our period is found by taking 2 pi and dividing by the B value, and since B is 2, we'll say 2 pi divided by 2 is pi. So the period is pi. To get our phase shift, we want to do C divided by B. C is pi. B, remember, was 2. So our phase shift is pi divided by 2. Our vertical shift is the D value, and the D value is 0. Alright, I'm going to start by sketching a graph of the parent function, including its critical points. So I want to start with the sine function. I know has 3 x-intercepts, so I'm going to mark those at 0, pi, and 2 pi. I know that the sine function has a maximum value of 1 at pi over 2, and I know the sine function has a minimum value of -1 at 3 pi over 2. And then I can sketch the graph of that function. It's not going to look too pretty, just pretend. So there's my parent function. Next, I want to graph the new period. We said the period was pi. So what that means is that the graph of our parent function will complete one full cycle in pi units. So that means it's three x-intercepts of 0, pi, and 2 pi are now going to occur from 0, pi over 2 to pi, because that function is going to complete one full cycle in pi. So I'm going to have a maximum now halfway between 0 and pi over 2 at pi over 4, and right here. So this is now the function y equals sine of 2x, because that b value changed the period right here. All right, next we're going to apply the new phase shift. So the phase shift was pi divided by 2, which means that this function is shifting pi over 2 units to the right. So that means each of these x-intercepts are just going to move pi over 2 units to the right. So that means our first point, instead of being at 0, 0, is now here at pi over 2. Pi over 2 is going to move to pi, and pi will move to 3 pi over 2. But nothing else is changing, so we're going to have our graph now looking like this. And so you can see here the graph still completes one full cycle in pi units, but we've shifted every x-intercept to the right pi over 2 units, and also shifting the maximum and minimum. If I wanted to write what does this function look like, it would be y equals sine of 2x minus pi, because all we've done now is shift the graph to the right with this phase shift. Why did I shift to the right instead of to the left? Because of the minus sign in here. If there had been a plus sign, I would have been shifting to the left. But because we had a minus pi over 2, we're shifting to the right. Okay, for step 4, we want to apply the new amplitude. So now we're ready to do that. We can see here that the outputs, the y values for the x-intercepts, are 0. So if we were to multiply those y values by 0, these x-intercepts would not change at all, because 0 times 3 is 0. However, we can see here that the maximum value of 1, if we were to take 1 and multiply by 3, we would get this max value now to be at 3. And likewise, we would have a minimum value of -3, doing this vertical stretching by a factor of 3. And so this is now the graph of our function. If I were to write what do I have now, this would be y equals 3 times sine of 2x minus pi. Looking at our step 5, we can see there was no vertical shift, so our step 4 graph is the completed graph. I will show you how we can check values in just a moment, but I'm going to go ahead. Let's do step 7, which is to continue the graph throughout the coordinate plane. So if I were to repeat my pattern, I would see another x-intercept here, a maximum here, and I could continue to sketch that graph on the right-hand side. I could also continue the pattern over on the left. I would have a maximum here, a minimum of here, and I could continue to sketch that graph over the entire coordinate plane, continuing my pattern again and again. And so be careful not to make your graph look like a V shape, because it's not. It should be a smooth curve. All right, and so that's the graph of the function. All right, I just want to show you how we can check our values, just a couple to see if we are correct. So here was an ordered pair, and that ordered pair was at pi over 2 comma 0. So what I want to do is I want to take my x coordinate, which is pi over 2, and plug that in. So we'll say 2 times pi over 2 minus pi. And I'm going to work that out. Well, 2 times pi over 2 is pi. And so I have 3 times sine of pi minus pi. Pi minus pi is 0. And sine of 0 is 0. And so 3 times 0 is 0. So you can see here that ordered pair checks out. So now I'm going to take this ordered pair right here. Halfway between pi over 2 and pi is 3 pi over 4. And that maximum value is 3. So I'm going to check my answer now by plugging in that 3 pi over 4. So right here I'm going to say 2 times 3 pi over 4. 2 times 3 pi over 4, simplifying that, becomes 3 pi over 2. And 3 pi over 2 minus 2 pi over 2, remember that, is pi over 2. So this is sine of, so 3 times sine of, 3 times sine of. And so the sine of pi over 2 is exactly 1. So we have 3 times 1 is 3. And so the output, when we put in the x value of 3 pi over 4, we got an output of 3. And so this is a way to confirm your graph makes sense. And of course, if you don't like the transformation way of doing anything, you can always plug in values and work it out that way to get your graph. I think that's a little harder to do myself, but it's possible.